if you have watched the previous video, you may have noticed that there is no x in the series, right? So in the previous video, we see that we have a summation where n goes from 1 to infinity, and then on the body of the series, you see some n, right? But in a power series, how do you know that a series is a power series? The answer is the n has an increment by 1, right? Because n goes from 1 to infinity. So the characteristic of a power series is you have x raised to the nth power. Again, the characteristic of a power series is that you have x raised to the nth power. So compare the power series to all the series to learn prior to this lesson is that in a power series, there is an x in it. So other than n, we also have an x in the power series. So I have an example for you. So the example of a power series is summation n goes from 1 to infinity. In the numerator, I have x raised to the n. In the denominator, I have 2n minus 1. So other than n, there is an x in it. So there is a general power series. So we have n equals to 0 to infinity. I have c and then subscript n, and then x raised to the n power. The green nth power is what makes this series becomes a power series. So if you take a look at the expansion, when n is equals to 0, x raised to the 0 power is 1, so that's why we only have a c0 in the first term. And then as x increased by 1, so you have c1 x raised to the first, c2 x raised to the second, c3 x raised to the third, so on and so forth. So this series has a power n, and n is increasing. So the x raised to the n is a characteristic of a power series. And then the c is a constant, so looks like a c is not changing at this point. And then x is a variable, n is a power. The power series may converge from some x. This is concept, and the power series may diverge for all other x value. All right, so the power series converges for an interval of x value or a set of x value. So if the x value is not within that interval or not within that set, then that x value will make the power series diverge. And the sum of the power series is a function. So basically we have f of x equals to the expansion of the power series. So compare the purple function and the red power series. Do you see that f of x is equals to the expansion of the power series? And then what about the domain? The domain is all the x value for which the series converges. And later on, we call that the interval of convergence. Again, the domain of the function is all the x value for which the series converges, and then the function is a polynomial that has infinitely many terms. So when we deal with power series, we have to find out what x value makes the power series converge, and that is called interval of convergence. So let's take a look at the next piece. So the next piece, we will have to use this every time we do power series. And if you watch the next video, I will remind you this every time I solve a problem. So I have to say the power series and geometric series. So what is a geometric series? So every time I mention a geometric series has a base. The base, we call that a common ratio r. So we have r raised to the nth power. So let's take a look at this geometric series. We have x raised to the n. So the x raised to the n is the characteristic of a power series, right? But since you have x raised to the n, then the x is served as a base, then x is my common ratio, right? So x to the n, so that will be when n is equals to 0, x raised to the 0 is 1. When n is equals to 1, we have x raised to the first, and then x raised to the second, x raised to the third, so on and so forth. So for the white handwriting, so this one is totally step back to the geometric series. So for the base r in the geometric series, we say the geometric series is converges when the common ratio, the absolute value of r, is less than 1. So using the language in power series, the base is not r, the base is x. So just substitute this language to our power series. We say that the base x, not r anymore. We say that when x is the absolute value of x is less than 1, so that implies x is between -1 and 1. So this one, you better write this down, because every time we solve a power series to determine the interval of convergence, in case if you think the language is too complicated, determine the interval of convergence is I see an x in the power series. So n is not an unknown, right? N has an increment of 1. N equals to 0, n equals to 1, to 3, to 4, 5, blah, 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 so on and so forth, right? So n is increasing, but x is a variable. So we have to figure out what kind of x value makes the power series convergence. So that is called the interval of convergence. And then every time you find the interval of convergence, you have to employ the concept of geometric series, which is you have to make the absolute value of the base, which is x, less than 1. So that implies that x is between -1 and 1. So more concept back in the geometric series. So let's say the base is 0.5. Why do we say that that is a converge? So 0.5 absolute value is still a 0.5, which is less than 1, because if that is equals to 0.5, you raise 0.5 to a very large power. So 0.5 raised to infinity, you don't get exactly equals to 0. If you take 0.5 raised to a very large value, you will get something that is very, very close to 0. Not exactly 0. You multiply 0.5 to itself a few times, you will not get a 0. But if you raise that to a large power, the result is close to 0, but not equal to 0. So we say that that is a converge. I said this when we were learning a geometric series. I said that is converged because the sum is only determined by the first few terms. So think about the expansion of a geometric series. When n is equals to infinity, that means the last couple term in the expansion, right? So the base raised to a large power equals to 0. So that means if you look all the way to the right of an expansion, those couple terms on the very right hand side, they are something close to 0. So they don't really affect the sum, right? Which means the sum is only determined by the sum of the first few terms. So that's why we know the sum of the first few terms is equals to a real number. As a result, the series is converged. This is not hard to picture in your mind. You are taking a calculus class, you have to make to this level or this lesson, you must be able to do this in your mind. All right, and then on the other hand, when the base x is greater than or equal to 1, for example, 1.5 raised to infinity, you will get a very large value. So that means if you look all the way to the right of the expansion, they are all infinity. So you are summing up a bunch of infinities. Of course, the sum is equals to infinity. As a result, the geometric series diverges. All right, so that is the basic concept of power series. In the next video, I will introduce interval of convergence and the radius of convergence. I see you all in the next video. Before I sign out, do you think I did a good job in this video? Did I explain the concept? Did I make the concept clear to you? If so, let me know in the comment section below. Like the video, subscribe to my channel, share the video for me. I'm sure many people are learning the same thing at this point. Thank you for your help. I see you all in the next lesson. Signing off for now.